comparing multiple representations. Okay, so multiple representations, what we're talking about with those are different representations of linear equations or linear functions. Okay, so we have our function as a function, as an equation, okay, written out, and we're going to keep those in slope-intercept form. Makes it really nice and easy for us to use them. Okay, we also can represent them as a table or as a graph. All right, and what we're going to do with these different types of representations is we're going to compare them. And our first concept is about comparing their slopes. Okay, so when we're trying to compare the slopes of these different representations for different lines, we first have to be able to get the slopes. We have to be able to find the slopes given these different representations. Okay, and the first one, our slope-intercept form function, is the easiest because our slope is always right there. Whatever is being multiplied by the x, that's our slope. So for this function, we call it f of x. So for f of x, the slope, which is m, is equal to 4. Okay? And now for my second function, which I call g of x. Okay, that's kind of how we name our functions. So this is f of x, g of x, and h of x. All right, and the first letter doesn't really matter. That's just telling us what to call it. The letter inside is telling us what our independent variable is. So we always are using x for that. But the outside letter is just a name. Okay. All right, so when it's in a table, you can use the slope formula. Okay, y2 minus y1 over x2 minus x1. All right. You can also count. All right, but you got to be a little more careful with this. So it's easy, since I've got double zero here, it's pretty easy for me to say, okay, x increases by 2, and at the same time, y, or in this case, g of x, decreases by 3. Okay, so my slope here would be negative 3, okay, my function or my y value over 2. And that would be my slope for this one. Okay, I could put these into my slope formula and get the same thing. And sometimes that's the best way to do it. It is easy to make mistakes here. Okay, it's often easy to say, okay, I got 2 over negative 3. But that would be not the correct slope. Okay, so you can use slope formula. You can use this method. Just be careful to make sure that you have your values in the right place. All right. And now my last one is going to be pretty similar to the table. Okay, find your intersections. Okay, and I can see that my line intersects there, and let's see, looks like right here. 1, 2. No, maybe right here. Well, I can see it intersects right here. Anyway. Okay. So we'll use these two. All right, my intersects. So I've got a point at 1, 2, 3, 4, 5, 6, 6, 0, and a point at 0, 2. Okay, and I can use slope formula. Okay, let's make this 0.1, 0.2. So y2, 2 minus 0, and then x2, 0 minus 6, gets me a 2 over negative 6, and I can simplify that to a negative 1/3. Okay? So now I've got my three slopes. I know that this has a slope of negative 1/3, this has a slope of negative 3/2, and this has a slope of 4. All right. Now I'm going to compare those. And basically all I'm saying is which one's less, which one's more. All right. So I would say my greatest slope is this guy right here. And what that's telling me is if I were to graph my line, this line, doesn't matter kind of where it crosses the y-axis. I'm not thinking about the intercept at this point. But the slope of this line means it's going to, this one, we'll make this our purple line, means it's going to be steeper than either of these other two lines. Right? So this one's pretty steep. This one, it's a negative, but it's also pretty shallow. Okay? It's negative 1/3. All right, so it's pretty shallow. And then this one is negative 3/2, so it's also going to be coming down in the negative direction. We'll use blue for this one. Okay, it's going to be coming down in the negative direction, and it's going to be coming at a steeper angle than my green equation. Okay, so it might look something like this. All right, and that's all I'm really thinking about. Okay, I would say f of x has the greatest, h of x has the least or the most shallow slope, okay? Because when we're talking about slope and the steepness of it, we're really talking about not whether it's positive or negative, but kind of the absolute value, okay? Which one's closest to 0? 1/3 is closer to 0 than 3/2. So this one is going to be a lot closer to being my x-axis, to being flat, horizontal. Okay? And then 3/2 will be in the middle. Okay? At being kind of steep, but not really too steep. Okay? And that's it.